Hello everyone. Our team is a robot package retrieval team. We are a three-member team which consists of Ethan, John, Haicho, me, and Victoria Won. Our advisor is Dr. Singh Monami. So the idea behind this project is that there were estimates of 210 million packets that will get stolen in 2021 in America. I was a victim of a package stolen, and this is really an issue because I have to deal with online return, and sometimes they make it really difficult and time consuming to get your money back with, like these things should not have happened in the first place. So that is our idea to solve this problem using a packet retrieval that's allow it to retrieve the packet and secure it in a secure location. So to brainstorm this project, we were asking a lot of questions, and ultimately these are some of the questions that we were asking ourselves, like what we need to do to implement this project. So for instance, would be how would we build a capacity, like we're gonna make our filament, how are we going to design the different stuff and how it's gonna fit everything together. One of the other thing is that we have to figure out how to do 3D printing, either it's at school or at home, or we have to buy one. And one of the issue that we also coming up with is that, do we want to do it 4-wheel drive or 2-wheel drive? And then we also want to do object recognition. um, that's just some of the idea that we're coming up with. And so from those brainstorming, we were formed that we want to do this project, and this is our target. So our objective is very much that we're gonna have an autonomous robot that check in live video feeds from the camera from the Raspberry Pi. Using the information from the camera, it will detecting the robot will actually detecting whether it would avoid the obstacle, like it's not a box, but it's not, uh, or it's gonna heading toward an object. So one is with the object. The objective is that the car will turn around, and then it will push the box back to the predetermined location, which is pretty much what our objective is for this project. So the plan is that, as you can see here, this is a flow chart for the our design. So what we have is that the Pi camera is gonna be stick with the Raspberry Pi along with a servo motor that allow it to rotating. Um, and then hooking up with the Raspberry Pi is the Arduinos, and the Arduinos is gonna control the motors and the pretty much the motors, the front and the back motors of this project. We also planning to using a PC or a laptop, just so that we can do the web application, so that we can improve the performance for the Raspberry Pi, because the Raspberry Pi doesn't have very strong hardware to deal with object detection that require TensorFlow's core, basically graphic core that make it better to run. Um, so we will design those. This is the design. Um, for the part, this is pretty much on the part that is finalized in the project. So the big part of this is the Raspberry Pi, the Arduino's, ultrasonic sensor, and we have the camera and the motor. Pretty much those are the big one, and here the list of other parts. So for SolidWorks, the start for a refresher, SolidWorks is a 3D modeling software that we use to draw and design custom part for the build robots. And you can see here on the left, this is a prototype of an adapter that's going between the wheel and the motor that we were supposed to use. On the right side, you can see that This is the camera holders for the Raspberry Pi camera we were planning to use. For next is the prototype to final. So on the left side, as you can see, we were designing a motor holders. Like you can see, those two hole is for the shaft to rotating. But when we printing this out, and then we will realize that we would need to improve it because we cannot glue this to the base of the robot because it's lacking the strength. So we improve it by adding these two hooks and make small adjustment to the design so that it fit better with our part and everything is more secure. So as you can see here, this is the underbelly view of our robot. This is the big motor holder design that you can see from the previous slides. It consists of the motor, and then these are the adapter that hook it up from the shaft to the wheel. And here's a front motor design. As you can see right here, it consists of two long stick that stick with the stick in an L shape, so that we were able to using the servo motor to moving the wheel right side, left side, or right side, turn left or turn right. Next one is a Cura to 3D print. So Cura is the software that we're using to print from the software to the actual 2D printer, because this requires a G code files, which is a short code. Basically, it's binary numbers. Basically, it's the instruction for the 3D printing to actually print stuff. So you can see here, this is the actual picture of the 2D printed holder. It actually works. So for next up is the camera and object detection. As you can see here, the first picture is the Raspberry Pi. So from here, we were using this connector, and then we hook it up to the camera. The camera is also hooking up to the servo motors, so allow us to rotate. So our objective is just pretty much let the camera would move continuously 180 degree back and forth always, so that it can view the environments. So object detection AI. So this whole purpose of this is that it allows it to run an object detector on Raspberry Pi. As you can see here, it's able to detect one of our team member as a person. But the thing with this is it's really slow. As you can see right here, it's like 1 to 2 fps. That's really slow. We weren't able to implement the using the computer, but we're just using the Raspberry Pi for now. So to implement this, we're using open source OpenCV Python that able to detect an object that already have free AI training models that able to see an object and detect it at what it is using the camera. And this is just the algorithm of the camera to that shows how the camera interact, the algorithm of how it interact with an object. So the first thing the camera see is this object in a box? If it's a box, then it would instruct the Arduinos to using the motors so that it can go around the box and then push it back. If it's not a box, then we detect it is an obstacle. If it's not an obstacle, that means it's empty. Then it will do nothing. If it yes, it would attempt to avoid the object by turning left or turning right. So here the Arduinos and the ultrasonic sensor. The Arduino is mainly responsible for controlling the speed of the motor, and it's also controlling the ultrasonic sensor. It basically is sending the PWM signals, which is the pulse width modulation signal, to the motor to control the speed of it. For the ultrasonic sensor, it just allows the robot to see like how close it to an object. It can adjust the distance beyond that. So here's some coding. It looks pretty it's pretty understand. So this is the coding for the ultrasonic sensor. So what that essentially does is that there's 2 pins in the ultrasonic sensor that are responsible for it. It has a trick P pin, which is one of the and the echo pin. So the trick pin is the one that sends a signal, and the echo pin is the one that receives a signal. So to start the trick pin, it will send a signal, the high signals, which is a 1 signals, pretty much high signals, and then we'll wait for 15 seconds, and then we will send a low signal. And based on these, when it is hitting an object and it's bouncing back, the low signal, the actual P pin would receive the signals, and based on the duration between those time between the trick pin, the trick pin send signal and the actual pin receive the signal, we were able to calculate the distance between an object and itself. And this is just some coding for the IR removes that we implemented. Pretty much it's just we taking the input from the IR remove and translate it into an hex number. It would translate to hex number, and then we're just using the hex number at the button. So when the button is registered, it would do something like you can see here. So when I say left arrows, it would actually move. It would print out left arrow is registered, and the servo is rotating to 145 degrees. So basically, yeah, that's how it moves from the left to right. And here's the motors. So the picture is showing a subset of this is early design that we're doing. This is basically how it works. Is there's a battery part that it power the motor controllers. The motor controller will send the power and control the power output of the battery pack to the motors. This allow the motor to move forward, backward, or yep, and powered by the 12-volt battery, which require like double A battery. This is the coding for the motor. So the motor is pretty easy to understand. There's only 2 pins responsible for most of the stuff. So the first, these are M1 pin 1 and M1 pin 2, which is located in the motor controllers. Based on the different combination of these, it will allow the motor to move forward, backward, off, or on. So for the conclusion, our car was able to move packets a various way. But then we found out that once packet is become too big or too long, it actually hinder the car because of the friction between the car and the motor is not strong enough to overcome that. And the camera that we implementing is able to detecting and identify the objects within its views of a scope of view. But the code that we implement for the robot, everything work as it should. But the thing is, the part that we printing for the 3D printer for the front design for the front motor design of the robot is not really working It gives us a lot of slack, and because due to time constraint, we were not able to reprint those to fix the issue. So we were not able to show turn left or turn right, but we were able to show that the servo motor actually turn left or turn right. So for the future improvement, so if we have more time and more resources, we would like to train the box's image for the camera of the Raspberry Pi, because right now it's detecting whether we show in the next slide, but it will detect a box at a couch, a TV, something like that. And we would also like to have a better hardware to run the object detection, that our Raspberry Pi is not able to deliver a acceptable time frame for the object detection. We also would want to fix the front motor design that was pretty flimsy and it's really not did not work as it should. So here is a demo of the project. This is the first video. As you can see, um, the recipe the robot was able to rotating. This is just this functionality. You can see it's pushing the box. Unfortunately, as you can see, the front motor wasn't able to we were not able to secure those, so it's pretty flimsy, but it worked. This box is actually pretty big, as you can see here. It had a lot of screw here, and it's actually pretty heavy, but the robot was able to detect that to just push it, and this is a remote that we're using to do that. As you can see, it can move pretty slow because of the weight, and the motor wasn't able to overcome those. Here's another example with the bigger box and with a water bottle in the middle. As you can see, it's really struggling to push the box because this is way heavier than what the motor can do. Here is the video that's showing how the camera works. So you can see here, it detects a box at a bed, a couch, but it's working nonetheless, and also detecting other stuff. That would be it. Here's our some of the references for this slide. Thank you for listening.